Hello there, and welcome. Tonight we are going to travel somewhere very far away and very quiet. Not down a road and not across an ocean, but out past the edge of everything familiar into the space between galaxies. This is the emptiest, oldest, most patient place there is. It has been waiting a very long time for you to come and rest inside it for a while. Intergalactic space is not a place most of us ever think about. We think about our own street, our own town, maybe the next country over if we are planning a trip. Occasionally we think as far as the moon because we have seen pictures of it hanging there over the rooftops. But beyond the moon, beyond the sun, beyond even our whole galaxy of 400 billion stars, there is a vast, dark, slow-breathing openness that stretches for distances so large that the numbers themselves stop being useful and start being something more like poetry. Tonight we will let those numbers become poetry. We are not here to memorize them. We are here to float inside them. This kind of space touches human life in a way that might surprise you. Every person who has ever lived and looked up at a truly dark sky has, in some small way, been looking into intergalactic space. The soft haze of the Milky Way above a quiet field, the faint smudge of the Andromeda galaxy that a patient eye can just barely catch on a clear autumn night, the light from stars that finished their journey to your eye before you were even born. All of it is a thread connecting your one small, warm, living body to something ancient and enormous and calm. You are, in this very moment, sitting inside that same vastness. It has room for you. It has always had room for you. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. Before we begin, let your shoulders soften. Let them drop away from your ears, just a little, the way a held breath finally lets go. Let your jaw loosen. Let your hands, wherever they are resting, stop holding on to anything at all. There is nothing to accomplish tonight. There is no test at the end of this. You do not need to remember a single fact. You only need to let your mind drift out, slowly, into the space between the stars, and let it stay there for a while. Let's begin. Space is mostly empty, and that emptiness is one of the most restful facts in all of science. If you could shrink the sun down to the size of a single grain of sand and place it on a table, the nearest star to it using that same tiny scale would be another grain of sand roughly 4 kilometers away. Almost everything in between would be nothing at all. No air, no dust you could see, no sound, no light, except the faint ancient glow of stars too far to warm you. This is true of the space inside our galaxy, and it becomes almost unimaginably more true of the space between galaxies. Out there, the nearest neighbouring collection of stars might be millions of grains of sand away, with nothing but a slow, cold quiet stretched between them. There is something deeply calming in this. So much of what worries us during the day feels large and crowded and urgent. But the universe itself, at its truest scale, is mostly just wide open room. Room to breathe, room to be small, room to rest. There is nothing you need to hold on to right now. Let your shoulders drop a little further if they have risen again while you are listening. Let us move on now to the galaxies themselves, the great islands that float in all of that open room. A galaxy is, at its heart, a very large, very old gathering of stars, held together not by any wall or boundary, but by the quiet, invisible pull of gravity. Our galaxy, the Milky Way, holds somewhere between 200 and 400 billion stars, turning together in a slow spiral, like cream stirred gently into coffee, except that this stirring takes about 230 million years to complete a single turn. You might pause here to consider that the last time our solar system was in the position it is in right now, relative to the rest of the galaxy, dinosaurs had not yet appeared on Earth. We are each of us riding on a very slow carousel, and we have only gone around it a handful of times since the Earth was young. Beyond our own galaxy there are others, many others. When astronomers point their most patient instruments into a patch of sky that looks, to the ordinary eye, like nothing at all, a small square of darkness you could cover with a grain of sand held at arm's length, they find, hiding in that darkness, thousands of galaxies, each one home to billions of stars of its own. It is worth pausing here for a moment, not to feel overwhelmed, but to feel something more like being tucked into a very large, very old house, with room after room after room, each one warmly lit from within by its own quiet fire of stars. The story shifts now, gently, to the shapes these galaxies take, because it turns out that galaxies, like people, come in many different forms, and each one has its own particular character. Some galaxies are spirals, like our own, with graceful curving arms that wind outward from a dense glowing centre, the way a pinwheel might look if you slowed its spinning down until it seemed almost still. Other galaxies are ellipticals, smooth and round or oval, like a soft dim cloud of light with no arms at all, made mostly of older, redder, quieter stars that have long since settled into a gentle, contented sprawl. And some galaxies have no real shape at all. Astronomers call these irregular galaxies, and they tend to be smaller, scrappier collections of stars that never quite organize themselves into a spiral or a sphere, and simply exist in their own asymmetrical, comfortable way. There is something reassuring in this variety. The universe did not insist that everything take the same tidy form. It allowed for spirals and spheres and untidy little clouds of stars alike. And every one of them is still, in its own way, a whole galaxy, full of light. From here, the story moves outward, to the space that actually lies between these galaxies, which is the true subject of our journey tonight. For a very long time, scientists assumed that the space between galaxies was simply nothing, a void, an absence. But as instruments grew more sensitive, they began to find that this space, while extraordinarily thin and cold, is not perfectly empty. It contains what is now called the intergalactic medium, a very faint, very diffuse scattering of gas, mostly hydrogen, left over from the early universe, drifting slowly between the great islands of stars. If you could gather up all of this gas from a region the size of your childhood bedroom, you might end up with only a single atom, or perhaps a few. It is a stillness so complete that it is difficult for the human mind, built for crowded rooms and busy days, to truly picture it. And yet this thin, patient gas is important. It is, in a sense, the raw material from which new galaxies can still occasionally form, drawn together over unfathomable stretches of time by gravity's slow and steady hand. You are in no hurry, neither is this world we're exploring together. Let us turn now to the question of distance, because distance out here means something different than it does anywhere else in your life. When astronomers measure the space between galaxies, they often use a unit called the light year, which is simply the distance that light, the fastest thing in the universe, travels in a single year. Light moves so quickly that it could circle the entire Earth about 7.5 times in 1 second. And yet, even at that almost incomprehensible speed, it takes light about 2.5 million years to travel from the Andromeda galaxy to our own eyes. This means that when you look at Andromeda on a clear, dark night, you're not seeing it as it is now. You're seeing a beam of light that left its stars 2.5 million years ago, long before any human being existed to look up and wonder about it. In a very real sense, looking into intergalactic space is a form of gentle time travel. You're always looking into the past. The deeper you look, the further back in time you go, all the way to a soft, faint afterglow from the very beginning of everything, which we will visit later tonight. There is something almost sacred in this idea if you let yourself sit with it slowly. The light touching your eyes right now from any star or galaxy above you began its journey long ago, patiently crossing an ocean of nothing, waiting for someone someday to be there to receive it. Tonight, that someone is you. Let your breathing find its own slow rhythm as we continue. From here, the story shifts to something astronomers call the local group, which is, in its own modest way, our galactic neighborhood. The Milky Way does not simply float alone in empty space. It belongs to a small cluster of galaxies, numbering somewhere around 80, all loosely bound together by gravity, drifting through space as a kind of family. The two largest members are our own Milky Way and the Andromeda Galaxy, each surrounded by smaller companion galaxies, the way a large old farmhouse might be surrounded by smaller cottages and outbuildings. Many of these smaller galaxies are what astronomers call dwarf galaxies, containing perhaps only a few million or a few billion stars. Modest by galactic standards, though still almost incomprehensibly grand by human ones. Some of these dwarf galaxies are so faint and diffuse that they were only discovered in recent decades, hiding quietly nearby all along, simply too dim and too shy to be noticed until we learn to look more carefully. It is worth pausing here for a moment to consider that even galaxies, it seems, prefer not to be entirely alone. They gather, gently, into small neighborhoods, bound not by fences or agreements, but by the soft, unbreakable pull of gravity, which asks nothing and simply holds. And yet beneath all of this gentle neighborliness, something quite dramatic and quite slow is unfolding, which brings us to the story of Andromeda and the Milky Way. Our galaxy and the Andromeda Galaxy are at this very moment moving toward each other, drawn together by their mutual gravity at a speed of roughly 250,000 miles an hour. This sounds fast, and in a sense it is, but the distance between the two galaxies is so enormous that this slow-motion approach will take about 4.5 billion years to complete. When the two galaxies finally do meet, they will not collide the way two solid objects might. Because the stars within each galaxy are spaced so incredibly far apart, it is unlikely that any two stars will actually strike one another. Instead, the two galaxies will pass through and around each other in a long, graceful gravitational dance, their shapes slowly distorting and merging over hundreds of millions of years, until eventually they settle into a single, larger, elliptical galaxy. Astronomers have already given this future galaxy a gentle nickname, Milkomeda. It is strange and rather beautiful to think that our galaxy's slow, distant future has already been named, long before it happens, by scientists imagining a night sky that none of us will ever see. If your eyes are growing heavy now, that is perfectly fine. Let them close. The story will carry on around you. Let us move now to the scale of things larger still than a single galaxy, or even a small local group, because galaxies themselves gather into even grander structures. Beyond the local group lies something called the Virgo cluster, a much larger gathering of well over 1,000 galaxies, and beyond that lies something larger still, called the Laniakea supercluster, a vast sprawling structure containing roughly 100,000 galaxies spanning a distance of about 500 million light-years. The name Laniakea comes from the Hawaiian words for immense heaven, chosen by the astronomers who mapped it, because they felt that no ordinary scientific term could quite capture the scale and the wonder of what they had found. Our entire local group, our galaxy, our sun, our small blue planet, and everyone who has ever lived upon it, all rest within one small corner of this immense heaven, gently flowing along invisible currents of gravity toward a distant, mysterious concentration of mass that astronomers have simply named the Great Attractor, for lack of a better way to describe something so large and so far away that its true nature is still being patiently studied. There is nothing urgent in any of this. These currents move at a pace so unhurried that they are essentially still, from the perspective of a single human lifetime. You could live 100 lives, one after another, and the sky above you each night would look almost exactly the same. From here, the story shifts to some of the strangest and quietest structures in the whole of intergalactic space, the great cosmic voids. If superclusters are the crowded, well-lit rooms of the universe, then voids are its long, dark, restful hallways. These are vast regions of space, sometimes hundreds of millions of light-years across, that contain remarkably few galaxies at all, sometimes almost none. One of the largest known voids, called the Bootes Void, spans a region so large that if our own Milky Way sat at its very centre, we would not have detected any other galaxies at all until the 1980s, simply because there was so little out there to see. Scientists sometimes describe the large-scale structure of the universe as resembling a sponge or a delicate web of soap bubbles, with galaxies clustered densely along the thin walls and filaments, and enormous, quiet, empty voids filling the space in between, like the air inside each bubble. It is a strange comfort to imagine that even the universe itself has rooms of rest built into its architecture, long, quiet stretches where very little happens for a very long time, tucked in between the busier, more crowded neighbourhoods of light. You might imagine, for a moment, drifting slowly through the middle of one of these voids. There would be no galaxy close enough to see with the naked eye in any direction, only a deep, soft darkness, and perhaps, very far off, the faintest whisper of light from a cluster of galaxies too distant to make out any detail. It would not be a frightening kind of emptiness. It would be closer to the stillness of a house at 3 a.m, when everyone you love is safely asleep down the hall, and the quiet itself feels like a kind of care. There is something else worth considering now, which is what actually connects all of these galaxies, clusters, and voids into a single, unified structure. Astronomers call it the cosmic web. If you could rise high enough above the universe to see its largest scale structure all at once, a feat no human being has ever actually accomplished, but one that astronomers have approximated through patient mapping of millions of galaxies, you would see something that looks remarkably like a web, or perhaps like the delicate branching pattern of frost on a cold window, or the root system of an old and enormous tree. Galaxies are not scattered randomly through space, the way sand might be scattered across a table. Instead, they are gathered along long, thin filaments and sheets, threading between the great voids, meeting each other at dense nodes where clusters and superclusters gather like knots in a piece of lace. This entire vast structure was shaped over billions of years by the slow, patient pull of gravity acting on tiny variations in the density of matter present in the universe's earliest moments. Variations so small that they amounted to differences of only a few parts in 100,000, and yet those tiny differences were enough, given enough time, to sculpt the entire architecture of everything we now see in the night sky. It is worth pausing here to consider how much can grow, slowly and patiently, from such a small beginning. A few parts in 100,000, given 14 billion years of unhurried time, became galaxies, clusters, filaments, and voids became, eventually, stars with planets, and planets with oceans, and oceans with quiet nights, and quiet nights with someone lying in the dark, listening to a story about how it all came to be. Allow your breathing to find its own slow rhythm as we continue further. Let us turn now, gently, to the question of what holds all of this together, which brings us to one of the most patient mysteries in modern science: dark matter. When astronomers study the way galaxies rotate and the way clusters of galaxies move and hold together, they find that there is simply not enough visible matter, not enough stars, not enough gas, not enough dust to account for the gravity required to keep everything in place. Something else, something that does not emit or reflect light in any way we have yet learned to detect, appears to make up the vast majority of the matter in the universe. Scientists have given this invisible substance a modest, almost humble name: dark matter. Not because it is sinister or threatening in any way, but simply because it is quite literally dark to us. It neither shines nor blocks light. It seems to interact with the universe almost entirely through gravity alone, quietly shaping the swan of galaxies and the paths of galaxy clusters, present in enormous quantities all around us and between the stars, and yet never once directly seen. There is something strangely comforting in the idea of dark matter if you let yourself sit with it for a while. It suggests that the universe is full of quiet, patient, invisible support structure and presence that does not need to be seen or noticed in order to hold everything gently together. You might think of it the way you might think of the unseen kindness in your own life. The friend who thought of you but never mentioned it. The stranger who once let you into traffic. The countless small invisible forces of care that have shaped your life without ever announcing themselves. From here, the story shifts to a companion mystery, every bit as strange and every bit as gentle in its implications: dark energy. In the late 1990s, astronomers studying very distant exploding stars called supernovae made a discovery that surprised nearly everyone in the field. They had expected to find that the expansion of the universe, the slow spreading apart of galaxies from one another, which has been happening since the very beginning, everything was gradually slowing down, the way a ball thrown into the air slows as gravity pulls it back. Instead, they found the opposite. The expansion of the universe is speeding up. Something is pushing galaxies apart from one another at an ever-increasing rate, working against the inward pull of gravity, and scientists still do not fully understand what this something is. They have given it a name, dark energy, but the name is in truth more of a placeholder for a question than an answer. It appears to make up roughly 70% of everything that exists in the universe, and yet it remains one of the deepest, most patiently studied puzzles in all of science. It is worth pausing here not to feel unsettled by how much remains unknown, but to feel something more like wonder. There is still so much left to discover. The universe has not finished revealing itself to us, and there is a kind of quiet, ongoing story still unfolding, slowly, patiently, night after night, as scientists continue to look upward and outward, asking gentle questions of a universe that answers only very slowly and only to those willing to wait. There is nothing you need to hold on to right now. Let your shoulders drop a little if they have risen. Let us move on now to a very different kind of object that lives out in the space between and within galaxies, The black hole, and in particular the enormous ones that sit quietly at the centres of nearly every large galaxy, including our own. The word black hole can sound frightening, and popular stories have often given it a dramatic, devouring reputation. But it is worth setting that drama gently aside tonight, because the reality is calmer and in its own way more beautiful. A black hole is simply a region of space where matter has become so densely packed that its gravity is strong enough to prevent even light from escaping. At the centre of the Milky Way, quietly present for billions of years, sits a supermassive black hole named Sagittarius, a star, with a mass about 4 million times that of our Sun. And yet, despite its enormous mass, it poses no danger whatsoever to us. It sits about 26,000 light-years away, calmly holding the stars near the galaxy's centre in slow, graceful orbits. The way a stone dropped into the centre of a pond might calmly organise the ripples around it. Astronomers have even managed in recent years to capture a real image of the shadow cast by a supermassive black hole, first in a distant galaxy called M87, and later of Sagittarius, a star itself, a soft, glowing ring of light bent around a dark, quiet centre, patient and still. You might imagine it not as a hungry mouth, as old stories sometimes suggest, but as something closer to a deep, quiet anchor, sitting at the heart of a great turning galaxy, holding everything gently in its slow and steady orbit, the way the quiet, patient love of a parent might hold a family together without ever needing to be loud about it. And yet, beneath all of this stillness, black holes are also connected to some of the most energetic and dramatic events that occur in intergalactic space, which brings us gently to the story of quasars. In the early universe, when galaxies were young and still gathering enormous amounts of gas and dust, some of the supermassive black holes at their centres grew very quickly, pulling in matter far more rapidly than the black holes we see in galaxies today. As this matter spiralled inward, it grew extraordinarily hot, releasing enormous amounts of light and energy, so much energy in fact, that a single quasar can outshine an entire galaxy of hundreds of billions of stars, all from a region of space not much larger than our solar system. When astronomers first discovered these objects in the 1950s and 1960s, they were deeply puzzling. Something that looked like a single ordinary star, and yet gave off more energy than seemed possible for any star to produce. It took years of patient, careful study to understand that these were not stars at all, but the brilliant, blazing centres of extremely distant young galaxies, their light having travelled for billions of years to finally reach our instruments. It is worth pausing here to consider that when we look at a quasar, we are looking not just far away, but far back into an era of the universe unimaginably younger than our own, a kind of glowing letter sent to us across an ocean of time from a version of the universe that no longer exists in quite the same way. Most galaxies, including our own, are thought to have gone through a quasar-like phase long ago, blazing brightly in their youth before settling over billions of years into the calmer, quieter galaxies we know today. There is something gentle in this too, the idea that even the most brilliant, most energetic phases of existence eventually give way to something calmer and more settled, the way a loud, bright childhood eventually gives way to a quieter, a steadier kind of adulthood. There is nothing you need to hold on to right now. Let your breathing settle a little more deeply. Let us turn now to the very oldest light in the entire universe, a soft, faint glow that fills every corner of intergalactic space, called the cosmic microwave background. About 13.8 billion years ago, the universe began in an extraordinarily hot, dense state, and for its first several 100,000 years, it remained too hot and too crowded for light to travel freely. Every photon was constantly scattered by the dense soup of particles surrounding it, the way light struggles to travel far inside a thick fog. But then, about 380,000 years after the beginning, the universe cooled enough for atoms to form properly for the first time, and space suddenly became transparent. Light was for the first time free to travel in a straight line, uninterrupted, and it has been travelling ever since. That very same light, extraordinarily stretched and cooled by nearly 14 billion years of the universe's ongoing expansion, still fills the sky today, in every direction you could possibly look, as a faint uniform microwave glow only a few degrees above absolute zero. Scientists call it the cosmic microwave background, and it is, in a very real sense, the oldest light there is a kind of gentle, ever-present afterglow from the universe's own infancy. You might imagine it as something like the warmth still faintly present in a room, hours after a fire has burned low in the hearth. The flames themselves are long gone, transformed and cooled, but a soft residue of that first great warmth still lingers, quietly, everywhere, filling the space around you, even now, even here, even as you lie in the dark tonight listening to this story. In a way you are, at this very moment, bathed in the oldest light that exists, so faint and so stretched by time that it can no longer be seen with the eye, only measured by careful instruments, but present nonetheless, wrapped gently around everything, everywhere, all the time. Let us allow the pace to slow further here and turn to something smaller and more intimate. The question of what would happen if you yourself could somehow drift, safely and gently, out into the space between two galaxies. Imagine, for a moment, a small quiet observation capsule, warm and softly lit inside, carrying you slowly out past the edge of the Milky Way, past the last faint scattering of stars, and out into the long dark hallway of intergalactic space. At first, the view behind you would still show the soft spiral glow of our galaxy, gradually shrinking, the way a familiar house grows small in the rearview mirror on a long, slow drive at night. Ahead of you, would be nothing but stars so distant they no longer look like individual points of light, but rather like enormous, hazy smudges of other galaxies, each one a whole world of billions of stars, reduced by distance to something soft and diffuse. There would be no wind, no sound, no sensation of movement at all, only the profound wraparound silence of true emptiness, and the slow, steady turning of the distant light. It would not be a lonely kind of silence. It would be closer to the silence of a library very late at night, or a beach before sunrise. A silence that holds you gently, rather than one that isolates you. If your eyes are growing heavy now, that is perfectly fine. Let them close. The story will carry on around you. Let us return gently to something closer to home, and consider the way that even our own solar system reaches out quietly toward that same intergalactic dark. Far beyond the orbit of Pluto, far beyond even the small icy worlds of the Kuiper Belt, there lies a vast, slow-moving shell of icy debris called the Oort cloud, thought to extend outward for perhaps a full light year or more from our Sun, nearly a quarter of the way to the very nearest star. Within this enormous faint halo, trillions of small icy bodies drift in slow, silent orbits, occasionally nudged by the gentle gravitational tug of a passing star, sending one of them tumbling over the course of millions of years down into the inner solar system, where it might eventually become visible to us as a comet, trailing its long, soft tail of ice and dust across our night sky. It is worth pausing here to consider that our own solar system does not end sharply, like the edge of a coin, but instead fades gradually, gently, into the surrounding darkness, the way the light of a campfire slowly fades into the surrounding night without any hard, definite edge. Even our own small corner of the universe, in other words, drifts softly outward, without urgency, into the same vast quiet that fills the space between galaxies. There is something else worth considering now, which is how astronomers actually manage to measure such enormous, almost unimaginable distances at all. One of the gentlest and most elegant tools available to them is something called a standard candle. Certain kinds of exploding stars, called Type 1a supernovae, are thought to always release almost exactly the same amount of total light, regardless of where or when they occur in the universe. This means that by comparing how bright such a supernova appears from Earth to how bright it should actually be, astronomers can calculate, with remarkable precision, exactly how far away it must be. It is a little like knowing that a particular kind of lighthouse always burns with exactly the same brightness, no matter where it is built. If you know how dim it appears from your boat, you can calculate quite precisely how far out to sea you must be. In this way, astronomers have used exploding stars, scattered across billions of light-years of intergalactic space, as a chain of small patient lighthouses, each one helping to measure the size and shape and age of the universe itself. Allow your breathing to find its own slow rhythm as we continue. From here, the story shifts to the stars themselves, and the quiet, patient process by which entirely new ones continue to be born within the great spiral arms of galaxies, and sometimes, more rarely, in the thin gas that drifts even in the spaces between them. Deep within enormous cold clouds of gas and dust, called nebulae, gravity slowly, patiently pulls matter inward, over the course of hundreds of thousands of years, gradually compressing and heating a dense knot of gas until, at last, nuclear fusion ignites at its core and a new star begins to shine. The Orion Nebula, visible to the naked eye on a clear winter night as a faint soft smudge below the 3 stars of Orion's belt, is one such stellar nursery, actively giving birth to new stars even now, this very night, in a slow, gentle, ongoing process that has been unfolding for a very long time and will continue long after we are gone. It is a strange and beautiful thing to consider, that even as you lie here, resting somewhere out in that soft smudge of light, a new star is quietly gathering itself together out of cold gas and ancient dust, patiently becoming something that will burn and shine for billions of years to come. You're in no hurry, neither is this world we're exploring together. Let us turn now gently to the eventual fate of stars, and in particular to a strange and beautiful category of stellar remnant that quietly litters intergalactic space, the white dwarf and its rarer, stranger cousin, the neutron star. When a star like our Sun finally exhausts the fuel at its core after billions of years of steady burning, it does not explode dramatically, but instead gently sheds its outer layers, forming a soft, glowing shell of gas called a planetary nebula, while its core slowly collapses into a small, extraordinarily dense object called a white dwarf roughly the size of the Earth, and yet containing as much mass as the Sun once did. A single teaspoon of white dwarf material would weigh, on Earth, about as much as a small car. These objects no longer generate their own energy through fusion, but instead simply glow faintly and steadily for billions upon billions of years, slowly cooling like the last quiet embers of a fire long after everyone has gone to sleep. Larger stars meet an even stranger fate, collapsing further still into neutron stars, so dense that a single teaspoon of their material would weigh roughly 1 billion tons, or sometimes collapsing further still into black holes, closing the story of a star's long life with a quiet, patient stillness that will last, essentially, forever. There is something gentle, even tender, in the idea that a star's ending is not always violent or dramatic. Often, it is simply a slow, graceful exhaling, a soft release of light and gas into the surrounding dark, followed by a long, quiet dimming that continues for longer than human history has yet lasted, and will continue for far longer still. There is something else worth considering now, which is the strange patient phenomenon of gravitational lensing, one of the more poetic tricks that intergalactic space likes to play with light. Because massive objects, galaxies, and especially enormous clusters of galaxies bend the very fabric of space and time around them, light passing near them is gently curved, the way a marble rolled across a stretched sheet of fabric might curve around a heavy bowling ball resting at its centre. When a massive cluster of galaxies sits directly between us and a much more distant galaxy, its gravity can bend and magnify the distant galaxy's light, sometimes smearing it into long, delicate arcs, or even splitting a single distant galaxy into several separate images, arranged gently around the lensing cluster like petals around the centre of a flower. Astronomers have even discovered a particular alignment, nicknamed the Einstein cross, in which a single distant quasar appears 4 times over, arranged in a soft symmetrical pattern around a foreground galaxy, all because of this gentle bending of light across billions of years and billions of light years of intergalactic space. It is a beautiful reminder that space itself is not a rigid, empty stage on which the universe simply happens, but something soft and responsive, gently curving and bending around everything within it, shaping the very paths that light must follow to reach us. If your eyes are growing heavy now, that is perfectly fine. Let them close. The story will carry on around you. Let us move now to a very old question asked quietly by nearly every civilization that has ever looked up at a truly dark sky. Are we alone out there, in all of this vastness? It is worth acknowledging, gently and honestly, that we do not yet know the answer. Scientists estimate that our galaxy alone contains billions of planets orbiting within the so-called habitable zones of their stars, regions where liquid water could in principle exist on a planet's surface, and our galaxy is only one among perhaps 2 trillion others scattered across the observable universe. And yet, despite decades of careful, patient listening, using enormous radio telescopes tuned to catch the faintest whisper of an artificial signal from somewhere out among the stars, we have not yet found clear evidence of another civilization. This has come to be known gently as the Fermi paradox, the tension between how likely life seems, given the sheer number of stars and planets involved, and how quiet the universe has, so far, remained. There are many possible explanations, none of them frightening, most of them simply patient reminders of how very large the universe is and how very young our own effort to listen has been. Perhaps civilizations are rare. Perhaps they are common but far apart in both space and time. Perhaps we've simply not yet listened long enough, or in quite the right way. There is a certain restfulness available in not knowing this answer yet. It means the story is still unfolding. It means there is still room for wonder, still room for discovery, Still room for someone someday, perhaps even you, to help answer a question that has been quietly waiting to be asked properly for as long as human beings have existed. You might allow your breathing to settle a little more deeply here as we turn towards smaller, more intimate wonders within this same vast dark. Let us consider, for a while, the sheer age of the light now touching your eyes whenever you look up at a genuinely dark, star-filled sky. Most of the stars visible to the naked eye are relatively close, cosmically speaking, and their light has taken only a handful of years, or perhaps a few centuries, to reach you. But if you were to look, even without special instruments, at the faint, soft glow of the Andromeda Galaxy on a clear night, you would be looking at light that began its journey 2.5 million years ago, long before modern humans existed, in an era when our ancestors were only just beginning to walk upright across the plains of Africa. That light travelled the entire time, patiently, silently, through the long, dark hallway of intergalactic space, never stopping, never resting, simply moving steadily forward at the same unchanging speed, waiting, in a sense, for someone to finally be there to receive it. And now, tonight, that someone is you. It took 2.5 million years for that particular beam of light to find you, lying quietly in the dark, and it has finally arrived, and it has finally been seen. There is something worth sitting with in that. You're not separate from this ancient story. You are, in this small, quiet moment, the destination of a journey that began before humanity itself. Let us move gently now toward a smaller, more delicate structures within this same great dark, the faint, quiet streams of stars called stellar streams that trail behind smaller galaxies as they're slowly, gently pulled apart by the gravity of larger ones. When a small dwarf galaxy passes too close to a much larger galaxy like our own, the larger galaxy's gravity does not always destroy it violently. More often, it does something slower and gentler. It stretches the smaller galaxy out over hundreds of millions of years into a long, thin, graceful stream of stars, trailing behind and ahead of the shrinking remnant like a soft ribbon caught in a slow current. Astronomers have found many such streams surrounding our own galaxy, faint traces of smaller galaxies that were once whole and independent, now slowly being folded, gently and patiently, into the larger structure of the Milky Way. It is, in its own way, a story of belonging, smaller things over long enough stretches of time, becoming part of something larger than themselves, not through force or violence, but through the slow, patient, inevitable pull of gravity, the same quiet force that holds your own body gently against the mattress beneath you right now. You're in no hurry. Neither is this world we're exploring together. There is something else worth considering gently as we move deeper into the later hours of this journey. The profound, comforting stillness of the timescales involved in nearly everything we have discussed tonight. A human lifetime, even a very long and full one, lasts less than a century, and yet the processes we have wandered through tonight, the slow drift of galaxies toward one another, the gradual cooling of a white dwarf, the patient stretching of a dwarf galaxy into a stellar stream, the steady expansion of the universe itself, unfold across spans of time so long that 100 human lifetimes, laid end to end, would still be only the smallest fraction of a single one of these cosmic stories. There is no rush anywhere in any of this. The universe has never once been in a hurry. It has taken its time with everything, patiently, unhurriedly, across billions of years, and it will continue to take its time long after tonight, long after this year, long after any of us. There is something deeply permission-giving in this. If the universe itself does not rush, perhaps you too do not need to rush tonight. Perhaps you too are allowed to simply rest, unhurried inside this long, slow, patient story. Let your eyes close now, if they have not already. Let your body sink a little more deeply into whatever is holding you. Let us gather ourselves gently and begin to draw this long, slow journey toward its close. We have travelled a very great distance tonight, though you have not moved from where you are lying. We began close to home in the quiet, mostly empty space around our own small planet and moved outward, slowly, through the vast spinning disk of our own galaxy, out past its edge into the soft dark hallway between galaxies, past the gentle gathering of our local group, out toward the enormous patient structure of Laniakea, and further still into the long quiet stretches of the great cosmic voids. We have considered the invisible patient support of dark matter and the mysterious gentle push of dark energy. We have watched black holes hold their galaxies together in slow, steady orbits, and quasars blaze brightly in the universe's distant youth. We have bathed, however briefly, in the oldest light there is, and we have imagined new stars quietly gathering themselves together, even now, out of cold and ancient dust. None of this needs to be remembered. It is enough that you travelled through it once, gently, on your way towards sleep. If you found some comfort in this journey tonight, I invite you, whenever you have the energy for it, to like, subscribe, or leave a quiet thought below. It helps this small, patient corner of the internet find its way to other tired minds who might need it too. For now, though, there is nothing left to do. Let the images we have travelled through tonight, the soft spiral of the galaxy, the slow drift of ancient light, the long dark hallway of quiet space begin to loosen and soften, the way a held thought loosens when you finally stop holding on to it. Let your thoughts lose their grip on the day behind you and on tomorrow ahead of you, and simply rest here, now, in this wide, dark, patient, endlessly gentle universe, which has all the room in the world for you to simply let go. Sleep well, and good night.